So for our next unit, we're going to be using a lot of the formulas that we've learned earlier in the year, like slope, midpoint, and distance. And we're going to use those to actually do some kind of like proofs of things to prove certain quadrilaterals are what we say they are. So before we get into all of that and how to do all of that, I want to do a day of just reviewing what the slope, midpoint, and distance formula are. Okay. You may remember them, you may not. Even though we've used them over and over again, I want to go back and just double check that we have a good understanding of them. So that's what this lesson's all about. Let's take a look at it. So we'll look at each of these things separately. We'll start with our distance formula. Okay. So the distance formula, if you remember, is, let me get a good color here. We usually use D for distance, although sometimes I'll use whatever the name of the segment is I'm looking at. And it had the big square root. And that is x2 minus x1 squared, y2 minus y1 squared, all under the square root. And if you remember, we actually talked about how this is really derived from the Pythagorean theorem, because you have something squared plus something squared equals something squared. But instead of squaring it, we take the square root. So the distance formula really is derived from the Pythagorean theorem. This is our one thing here is how far along the x-axis we go, how far along the y-axis we go. We even looked at, when we did this on a coordinate plane, how you could make little right triangles and just use Pythagorean theorem. But sometimes you don't have the ability to graph that, so it's good to have these formulas that we can calculate these distances with. Now, what does the distance formula tell us? Well, distance, that makes sense. It tells us how long segments are, okay? The length of a segment. So we could actually use our distance formula to tell if two segments have the same length. And we call those segments what? Congruent. Good. So two segments that have the same length are congruent. And we can use our distance formula to show whether two segments are congruent or not. Now I'm saying segments, but when we talk about this with polygons, we're looking at it whether two sides are congruent or not. Okay, so let's just do a basic little problem reviewing our distance formula. We've got 4 points here, A, B, C, and D, and we want to find out, is segment AB congruent to segment CD? So we're just going to do our formulas. Now, I do encourage you, write all of this out. Notice we've got a lot of different formulas coming up here. Each equation is going to lead me to different things. So write this out and use your labels. So AB, I'm going to find that distance. Notice I didn't put a segment symbol over AB. That's because when I write AB without the symbol, it actually is read as the length of AB. So I'm saying the length of AB is, now x2 minus x1. So x2 is -1 minus x1, which is -3, and minus the negative is +3. All right, so y2 minus y1, 5 minus 1 squared. Always take the moment to write that in. Yes, I know you can throw it in a calculator, but it's so easy to make errors. You'll be able to find your errors again if you write that down. Now it's a matter of doing the calculations. Don't forget your square root. Some people, they're doing like scratch work in between here, and they'll go, oh, I'll put the square root in at the end. It's bad math. It's bad communication. It's like when you're writing and you don't capitalize at the beginning of a sentence, or you don't put in punctuation. You are trying to communicate in mathematics. So keep all of the appropriate symbols. So 2 squared and 4 squared. 2 squared is 4. 4 squared is 16. That's going to give me the square root of 20. Now, because I'm comparing lengths, it's going to be easier to leave it there. Hey, leave it as the square root of 20. If I needed this in reduced radical form, well, let's see. 20 breaks up as 4 and 5. So square root of 4 is 2 times the square root of 5. So there is the length of AB. And I like to keep both of these. The radical form version tells me my best answer, but the square root of 20 version is a way I can look at that and compare it. So here's my question for you. If CD is congruent, what do you expect CD's length to be? Now, that seems like a very easy question. I want CD hopefully to be the same thing, square root of 20 or 2 radical 5. So now it's your turn. I want you to find the length of CD. Use your numbers carefully. We'll take a look at it at the end here. Find me CD. So you put your numbers in. Let's see. X2 is 1 minus 2. Watch your signs there. You're always adding in the middle. -1 minus 4. Hey, by the way, if you switch these, if you did 2 minus 1, 4 minus -1, same thing, okay? You should still get to the same place when we square things. So that's -1 squared, -5 squared. So that's 1 plus 25, which is square root of 26. At this moment, I know just by comparing, let's see, AB is square root of 20, CD is square root of 26. Let me write a CD in there so I know what I'm looking at. I now know that no, these are not congruent. So I'll answer my question. Always go back and answer the question that's being asked. Don't just leave it sitting like that. So I can say no, AB is not congruent to CD. And I've got the work to back it up, okay? There's certain things you need when you're backing up your work. You need to show that you put the points in properly, okay? That's why it's very important to have that written. I don't want to see just, oh, here's my answers, because I don't know where you got those numbers from. I need to at least see that you put your points in, okay? Then I need to see what it calculates out to be. Then I need to see that you answered it, okay? So that's why it's important to go through all of these steps. That's sort of your convincing arguments, okay? There we go. That's distance. That's easy. What about slope? You'll be amazed at the number of people that tell me slope is y equals mx plus b. That is not slope. That's the equation of a line. Our slope formula, I'm going to change colors here so we can see it differently. Let's go with the brown color. That's going to be fun. There we go. So our slope, what letter represents slope? Hopefully you said lowercase m, not capital M. In mathematics, it has to be a lowercase m. And slope is really the difference of the y's minus the difference, or over the difference of the x's, I'm sorry. So the change in y over the change in x. That's my basic slope formula. That's all it is. Slope we can use to show a bunch of different things. Now, yeah, it's used in the equations of lines, but we can look at slopes and go, hey, I know things about slopes. If two slopes are the same, what do we know about the lines? Okay, they should be parallel. Well, kind of the other version that we could look at, we know lines are parallel, or they're not parallel, or they're not parallel in a special way called perpendicular. Whoop, can't spell. Perpendicular. Okay, so what do you know the slopes of perpendicular lines have? You should have said opposite reciprocals. So our two important key terms here are that the slopes of parallel lines are equal slopes and perpendicular lines are opposite reciprocal slopes. And two things there. Opposite means the sign is different, okay? Positive versus negative are opposites. Reciprocal means the fraction is flipped over, okay? So flipping the fraction is not an opposite. That's something that people get mixed up on. In mathematics, when we say opposite numbers, we mean positive versus negative, okay? So using that, we can go ahead and calculate some slopes. So let's take a look at this. Two problems here. Same points. Is AB parallel to CD? Parallel, the minute I see that, I think, hey, I need to look at slopes. So the slope of AB, notice how I did that. Little m for slope, but I did that sub AB to let me know that this is the slope of which line I'm dealing with, rather than just say slope and slope and slope and slope and slope, because I may have 4 or 5 slopes I'm dealing with, so I need to keep them separated. So my change in y's will be 5 minus 1, and then -1 minus -3. Minus a negative changes to a plus. So that's 4 over 2. Watch your signs, which gives me a slope of 2. So the slope of segment AB is 2. If I want CD to be parallel, what should the slope of CD be equal to? Like I said, parallel slopes should have parallel lines should have equal slopes. So my slope of CD should be 2 if they're parallel. Let's test it and find out. So change in y's, -1 minus 4, 1 minus 2. So -1 minus 4 is -5 over -1, which is a +5. So the slope of CD is 5. Are these lines parallel? No. AB is not parallel to CD because they don't have the same slopes. And again, the same deal. Information you need to show me to convince me. I need to see that you substituted your points in properly. And then I need to see what those final slopes are. Then you can answer your question. Let's look at another one. This time perpendicular. AC and BD, so they're different. So the slope of AC is going to be, let's see, 4 minus 1 and 2 minus -3. So that's 3 over 5. That's pretty easy. Slope of AC is 3/5. If I want these to be perpendicular, what should the slope of BD equal to? So you should have said that, hey, I need the opposite reciprocal. So 3/5 is positive, so I want it to be negative. And 3/5, flip it over, 5/3. So I want my slope to be -5/3. Go ahead, calculate the slope of BD. So calculating the slope of BD, so BD, that's going to be a -1 minus 5 and 1, -1 minus 5, yes, and 1 minus -1. 1 minus -1. Be careful with that. That's a mistake people make easily. So that's -6 over 2, which is -3. Are AC and BD perpendicular? No, their slopes have nothing to do with each other. They're not perpendicular. They're not equal either, so they're not parallel. So AC and BD are just two lines. They will intersect, okay, because they're not parallel, so they're going to cross each other, but they're not going to be perpendicular. They're not going to make right angles. So AC is not perpendicular. No, there's no symbol for that. To BD. And there we go. So that's how we can use slope to look at things. Now remember, perpendicular lines make right angles. If I have a quadrilateral and each consecutive side is perpendicular, then I have all right angles, which sort of tells me what kind of thing I'm dealing with there. Okay. So we've looked at distance to prove lines are congruent. We've looked at slope to prove whether lines are parallel or perpendicular or nothing at all, but just basically intersecting. Last one we want to look at is midpoint. So midpoint is basically the point in the middle of a segment, the point dead center in the segment. It's the point that is the average of the endpoints. So midpoint, you can use any capital letter to be midpoint. I tend to use capital M, but if I'm given a name for my midpoint, I'll use whatever letter they are. Remember, you use capital letter because it's a point, and it's in parentheses because it's coordinates. So x2 plus x1 over 2, that gives me my x coordinate, comma, y2 plus y1 over 2. When we did this, some people were doing some silly things with this, okay? Some people were putting the x in parentheses and the y in parentheses because I'd say, hey, don't forget your parentheses. So they put parentheses everywhere. The parentheses around the coordinates of the point, the x and y coordinate. In between is a comma, okay? Pay attention to what you're doing. When you start putting stuff like that in, it makes me think you're not really thinking about what's going on. You're just calculating some numbers and getting stuff done, okay? So pay attention to what you're doing, communicating in mathematics. Now, if two segments have the same midpoint, we can say they bisect each other, okay? So if I've got a segment here and a segment there, and this point is midpoint of that, and the midpoint of that, then notice both segments cut each other in half because they have the same midpoint. It does not mean that all four segments are congruent, okay? It does not mean that this segment is congruent to that segment. It just means these 2 points are congruent and those, or 2 segments are congruent and these 2 segments are congruent, okay? So we've got it. That's something to keep in mind. So my first question, do AC and BD bisect each other? So let's find the midpoint of AC. I'll call it M for midpoint. And because I don't know if they're the same, I'm going to call it M of AC, okay? So that's the midpoint of AC. My X values, 2 and -3. So 2 plus a -3 is the same as -3 divided by 2. And 4 plus 1. Remember, your midpoint is just the average of these. So the midpoint of AC, 2 minus 3 is -1 over 2, and that's 5 over 2. Go ahead and leave these as fractions, okay? Don't give me -1/2 and positive, 2.5. Don't give me -1 or -0.5 and -2.5. Don't give me those kinds of answers. Leave it in fractions. It's easier to compare. Let's find the other one. Now, here's my question. If these bisect each other, what should the midpoint of B, I can't write for some reason. I think my arm was on something. BD. What should that midpoint be? So hopefully you said, well, if they're bisecting each other, it should have the same midpoint. So it should be -1/2, 5/2. Let's see if it is. So BD, I'm doing 1 plus -1 over 2 and -1 plus 5 over 2. So looking at those numbers, make sure we got the right thing. 1 plus -1, -1 plus 5. Okay. So that means the midpoint of BD is 1 minus 1 is 0. And 0 over 2 is 0. And 1 minus 5, or -1 plus 5 is 4. 4 divided by 2 is 2. So here we can say, hey, these two things, they don't have the same midpoint. So no, they do not bisect each other. So AC and BD do not bisect each other. Now, that doesn't mean that one of these doesn't bisect the other one. Maybe BD cuts AC at the midpoint, but BD's got a longer piece to one end. You know, it could look something like this, just sort of sketching a picture of it. There's AC, there's the midpoint, and then I could draw BD. It may not even be perpendicular. So it may cut that in half, but it's not cutting BD, and AC doesn't cut BD in half. So we don't know what this looks like, okay? This is just a guess. I don't know. Maybe that's what it looks like. Maybe it's not. So there we've got our information, though. So you've got some work to do. Just using these formulas. Go through them and be careful. Again, as you're doing this, and not in this particular lesson, but there will come a point in which I'm going to make you use this Cami to actually write things down. And I want to be able to see that you're putting in the points. That's the first piece of information to prove to me that you know what you're talking about. I want to see what your midpoints are. And then I want to see an answer. Okay. That's what we're going to be practicing on in this unit. We may be doing quite a bit of writing on the screen. So if you need to get yourself a stylus or something for your touch screen, that's fine. You can get stylus that look like pens, and they got a little soft end on the end of them. Or you can use your finger to write on the screen. So just be aware that we will be doing that soon. Okay. Not tonight, though. Tonight, you've got a quizzes to do. Go through it very carefully. Answer the questions very carefully. Have some paper and calculator with you. And remember, fractions are fun. Fractions are your friend. Okay. See you in our next lesson.